So you
Let's
start
do it.
streaming, and that's OBS broadcasting to YouTube. I'm gonna check the feed on YouTube. There's 2 people waiting already.
Oh boy.
Oh boy.
Never done a live stream, so it'll be interesting.
I did one a while back. It was called Engineer Me Anything. That was it was another Reddit one. So I got a bunch of people to just put down ideas for like the stupidest things we could make, and we ended up engineering an automatic toilet paper disposal machine. It was like a 6 shooter for a toilet paper. So you use the roll up, and then you'd hit a button. It would like let it go, and then you go, and it would load another one on.
That's amazing.
I don't think anyone ever printed it. I certainly didn't. It was pretty bulky. Oh look, sweet. This is YouTube plus YouTube in YouTube in YouTube. Okay, so I'll get off that. Obviously it's working. We got 2 watching. Is there a control panel? Hello, 2 people watching. My name is Paul. And this is my new friend Jay. I'm going to point down because he's below me.
And you're above me, so I'll point up.
Cool, cool. I can close that. Today, yeah, we're going to be doing the first ever Beta Things 2-hour prototype session live. So it's going to be like design improv between me and Jay here. Jay had the idea he wants to make a table for his couch to go like between the couch cushions and then leave a little surface, and we're going to put drinks. And I think we talked about like a snack tray of some kind.
Yeah, we can fit it in there somewhere.
Yeah, for
I'm
sure.
mostly about soda.
Yeah, mostly about the soda. And Jay's done all the prep work. He's got all these measurements for me, so I think we're going to knock it out pretty quick. I don't think it's going to take 2 hours, but we'll definitely put in the time necessary to make it nice. My design criteria are it's got to be elegant as shit. It's got to be quick to print. And I don't want to print stuff that's not necessary. So we're just going to focus on the functionality and then sort of build around it from there. We're using Onshape, which is, anyone that's been watching for a while knows that I friggin' love Onshape. It's my jam. It's like SolidWorks, but free. Nice. So we're going to create a new document, and we're going to call it, what do you want to call this thing?
Oh boy, that was the one thing I didn't think about.
Yeah. It's got to be trendy, right? We're going to start a Kickstarter or something for it.
Exactly. So we have to come up with a good name right off the bat.
Yeah, like platform, like a comfy, cushy like a platform in the sky almost on clouds, because the clouds are like the cushion.
Mm-hmm.
Was there like an airship that was like there was like an airship in one of those superhero movies? It was like a boat, like a giant like Navy fleet boat, but it had these like propellers or whatever. You remember that one?
In a superhero movie?
Yeah, I forget which one.
Yeah, I'm not.
It was like a Captain America or something. Oh well, if we could get the name of that boat. Is anyone in the feed? Someone, Matt Johnson. Why don't you give me a friggin'?
Yeah, I'll take ideas.
All right, you take ideas. Okay, for now we'll call it. Oh damn.
Soda platform.
Sofa platform?
Like soda platform.
Soda.
Maybe we could do a play on the sofa soda.
Sopa.
They're too similar. Soda platform.
Soda platform. All right, let's just not put too much into that. We'll call that the working title. It's descriptive. Okay. And I'm actually... I should also pull up your that nice drawing you sent me. Well, you sent me that over Skype, didn't you?
Oh boy. Yeah.
Can you
I
just
do have it here as well?
Yeah, can you just hold it up for me so I can see it?
There we go. My beautiful drawing.
Yeah, perfect. Okay. So I'm just right off the bat. I'm thinking print orientations. I'm thinking number of parts. So I'm thinking probably 3 parts here, actually.
Okay, 3 parts? Okay.
Yeah. So we do like the top plate area, the sort of downward member piece, and then the bottom flat plate. And I'd probably have those all, yeah, sort of slide fit together. That way we'll be able to play around with some geometry a little bit more, and do some things. If we tried to print it all at once in one place, we'd be dealing with a lot of overhang issues.
Supports,
Yeah, and supports. I don't want to. I don't want to deal with. Try to make it as easily printable as possible. Okay, cool. So let's start with the functionality of it. We want 2 soda cans. You can take the drawing down. I'm good.
Yeah, 2 soda cans would be great.
2 soda cans.
Yeah,
and
I
like
don't like maybe some kind of bowl shape for snacks. I don't know if I'll use it that much though.
yeah, I was thinking about that actually earlier. Either it's cool to like build the bowl shape into a 3D printed item and just like throw your Doritos or whatever in there. But like the nature of yeah, the nature of FDM, you just get all those ridges and stuff gets stuck in there. But maybe like just an area for a bowl. We could do like a little, just like a recessed area for a bowl. You'd know where to put it. Be hard to knock over. Okay.
Yeah, that sounds good. That works.
All right. So Jay, you've been impressing me already. Do you have measurements on a soda can?
I do.
Yeah. So
Well, I have the diameter of 65 millimeters.
65 millimeters. Okay.
I do not have the height, but I can get that.
Right on.
Maybe. I'm using a full soda can here right now, so it's kind of precarious. So if we need it, I have about 120 millimeters for the height of the
120. Okay.
Yeah.
65 by 120. I'm just sort of roughing things out right now. Obviously, these aren't really nice cans. If I wanted to, I guess I could make those look more like cans, but I'm not. That's just extrude. But yeah, I just want to see sort of where things will be. Sort of give an idea of what a standard bowl would look like, I guess.
Do we need a measurement of a bowl? I can grab that as well.
Yeah, let's see your bowl. We're doing this. This is your thing, so.
I'll go grab one here.
Sure. I'll just sketch on the idea of a bowl right now for some reason. We got 2 people watching. Comment, please, so I know who you are. Watch, your bowl's gonna look nothing like the bowl I'm working on right now.
Just basic bowl.
Yeah, that's actually not bad. Perfect. Alright. I like splines and I hate splines. You know what a spline is?
Is it that squiggly shape right at the edge of the bowl?
Yeah, T-splines. They use them a lot. They use them a lot in like Photoshop and Illustrator and stuff.
Oh yeah.
And like if you're good at using them, you can make things look nice, but like my shit always ends up like all knobbly and stuff. Try to use as few control points as possible just so it doesn't end up being all weird, but so yeah, measurements would be helpful, I guess, at this point.
Yes. It looks like we have the actual rim of the bowl is going to be about 156 millimeters across. Oh, probably about 160 millimeters, because it's just slightly too large for my calipers here.
Okay, cool.
But since that's going to be sitting over the top of it, kind of, that's the lip, maybe 155 millimeters.
Well, right now I'm just trying to replicate the bowl as much as I can, and then we can work around that afterwards.
Oh, I see.
So,
Okay.
okay, so that's the top rim. What's the height? Can you, if you can get it?
Yeah. The height is going to be 50 millimeters.
50. Okay, and then give me just a close-up of the bowl so I can try to get that curve a little bit. Yeah. Oh, this is freaking splines. It's much more subtle than what I'm doing here. Subtle, subtle. Something like that. And then, yeah. Splines. Alright, I got it. Cool.
Okay. Okay. So all you're doing right now really is kind of drawing it in.
Yeah.
And
Oh,
then we'll,
can you get me the bottom sort of circle? I don't think it's this wide on yours. Can you get me a
yeah.
measurement sort of roughly across that?
Let's see here. I'm gonna trace it and try and get it here. Okay, so a very rough estimate here is going to be about 110 millimeters.
110.
Yeah.
Yeah, that's better. All right. So there would be kind of a tight, nice tight configuration of all three.
Nice. Yeah, look at that.
Okay.
That's pretty awesome.
All right. Well, we're just getting started. So, probably only want to hold the bowl or cans by what? Like, this is why we all have calipers on us, because it's so much easier to get an idea. I don't know, maybe how much would you need to hold something from like knocking over? Like maybe 25 millimeters?
Let's see. In the bowl, yeah, since it's so wide, probably not much. In the soda can,
I mean, you're not driving a car, but I guess if you're like getting active on the couch, that could be.
playing a cool video game.
Yeah.
Getting active on the couch.
35?
35? We could probably do 25. I think 25 would do it on a soda can. That's about 3/4.
Okay. All right. Cool. Let's do something fancy. Let's do something fancy. I gotta move us so I can get my cube here. Okay. So I'm gonna try and do some curve intersection stuff.
Okay.
And it's how we get kind of a nice, smooth, professional looking product. And the way I've been doing it is typically just through the intersection of curves. And Onshape's just released a lot of new features that make it a lot easier to do. So it's pretty cool. It'll make more sense. It'll make more sense in a minute.
Yeah.
Hey Jay, thanks for doing this with me.
Yeah, no problem. It's something that I've always wanted to learn how to do and kind of get into designing stuff.
Yeah.
But I've never. It's something that takes a lot of time to figure out. And whenever I would start something, I'd always have an idea like this, and then I'd have to open up Fusion 360, which is what I was trying to learn beforehand. And I'd open it up, and then I'd see the very first thing, and I'd be like, okay, what's that? So I'd go off to Google it. I'd figure that out. I'd go and do that quick, and it's like, oh, what's this? And I have to stop and go Google it, and it just takes so much time to stop, check it, stop, check it. So having something like this where I can be like, well, what's a spline? And you're like, oh, it's just this.
Yeah,
Oh, okay, that makes sense.
I get it, man. It's a lot of work doing the learning on your own, and then having someone show you. It's just like, oh, done, perfect. Let's move on.
Exactly.
So this thing's gonna look kind of like an old-timey telephone.
That's okay. That looks kind of cool. I was just
You reading
thinking.
that?
I was just thinking of a square with like a T base, upside down T base. So this looks.
Oh, this is
a
just
lot
the
better
start.
already.
This is just the top part of the table here. We'll get to that in a bit. How are we doing? We are at like 12 minutes. Oh, hold on. I got my friend Matt asking for a link. Just take this off
Okay.
screen. Should probably take that off the. Matt, go to my YouTube. Do I still have that copy? Yes. There you go, Matt. Sorry, it's one more viewer, and he'll look up stuff for us and run color commentary.
Yeah.
Okay. Cool. So that's that. And we'll do. We said 25 was fine, and then we could probably swoop down a bit for the bowl, even because, like, how much does a bowl really need? It's gonna look nice. It's gonna look real nice. So I guess I should try to teach you some basics as I go here. It's everything is based on sketches.
Okay.
And so you see I'm sketching now.
Mm.
And a sketch is just a drawing that's drawn on a surface, a flat surface, or like so a plane, like our right, front, and top planes, can be sketching surfaces. The bottom of this bowl, bottom of these cans are flat. They can be sketching surfaces. And the cool thing about parametric sketching is that we use numbers to define how the sketch is. And so after we've designed something and it wants to be changed, we can go back to that sketch, change what numbers define its shape, and then recompile the object.
Okay. So it's really intuitive in that you can just go back, change it a little, check it out, change it a little, check it out.
Exactly, yeah. It makes prototyping really easy. You can see on the left side here, this is the timeline we're creating. So it's every move that I've made in order. And I can scrub back through. I can scrub back through this timeline and make changes. I'm inside a command right now. But if I wasn't, I could scrub back through and go to different points in the timeline, add something, change something. So
that's really nice.
Very powerful. It's my fave. SolidWorks. Fusion 360 does implement this. But it's not by default, and it's a bit strange to me. But I guess I've been using this for 2.5 years now, so that's bias.
Yeah, I think the biggest thing that gets me in Fusion 360 or any kind of SketchUp program is trying to picture that 3D model in a virtual plane. It's like it's hard to figure out where the thing's gonna go.
I get you there, man. Yeah, I get it. It's almost like once you start doing it, and once you start 3D printing things, and then having that sort of handheld tactile feedback, and you go through the design process, you start to look at objects differently. Like simple objects like this, I'll look at it during a day and imagine how I would draw it. And so like I would look at it and be like, okay, well the cut part is obviously a revolve. So I'd draw a section of it. I would draw a sketch that defines this and that, and then I'd revolve it and thicken it. Like it just starts happening. You'll start to see the process behind what you're interacting with or trying to design.
Okay.
Yeah, so that covers at 25. It's kind of an interesting-ish curve. Okay, let's see what that does, I guess. We use a loft as a surface, this to a chain of objects. This plus this. I wonder if Matt's here yet. Matt, say something if you're in the chat, man.
Did I tell you that the soda can was 120 millimeters high?
Yes.
I don't know what I was saying because I think, oh no, this is in inches. Aha. I was like,
it's about 3.5 millimeters tall. I don't know.
I'm like, what is going on here? There we go. Okay, it is right.
Okay, cool.
I must have hit inches, and then I must have seen 0.25 or something. And I'm like, oh yeah, that's 3/4 of the can. And I'm like, wait, it's not quite right. We gotta figure it out. Yeah, that should keep it from tipping over.
I have to draw some guides here. You see what's happening is when I try to fill these lines with a surface, or with a surface, it just drops off really quickly. Tries to get down to that flat. So I'm just gonna draw another curve here that goes down to this edge, and it'll define how that should swoop down. Might have to do a few of them.
Okay.
Let's hide this and this for now. So I'm going to do a sketch on the front plane. I'm going to use simple spline, just 2 points. Start off by just putting them in random places in the air. And that's when I start using the parametric capabilities. What Onshape does really well is allows you to reference things within other things. So we're in a sketch right now, and I'm going to reference this other sketch you can see floating in the air in gray. So what I want is that this point should be pierced by this line, and I use the pierce command, and it puts it right there. And also I want this point to be pierced by this line. I give it a pierce coincidence. It actually happens way back here, where I didn't expect it to happen. And then just mess around with my control points to give myself a nice curve. And then when I try this fill again, hopefully I can use that as a guide, and it won't be as, oops, as a guide. I want that. Pops up. That's nice. It does pop up. But I think I need one more over here because it starts to fade out.
Yeah, I see what you're saying there.
And even I just want it more normal to this. I want to be coming out of that surface. Let's try an experiment. It's experiment time. So quickly, just did a sketch on the front or the top plane, created a line. I'm going to use that line to create a surface. Line angle, it's 90 degrees. New plane, and I'm going to do a sketch on that plane, which will be another simple spline. And I want you pierced by you, and you pierced by this guy maybe, and pop it up and up. This is going to start looking really weird and lumpy the more I do this, but we'll see. So there's that. I'll take this fill. You can actually drag things around in the timeline too, so I'm going to make the fill happen after that sketch so I can reference that sketch.
Okay.
Oh, of course. in this sketch, it's gone red because I referenced I
Don't
referenced
let
the
it
fill
happen.
in the sketch. But the good thing about Onshape is it fails gracefully. It just stays where it was, so it should be fine. Anyways, and we'll give it another guide, hopefully, here. No? Can't have another guide, can I? Well, fine. That sucks. Wonder if it would work better if I just used that one. No, you don't like that one at all? See, this is my day though. Is like trying
Yeah.
weird shit and being like, fuck.
Well, that's the designing process, right?
Totally.
I mean, yeah.
So
There's so many times I'll be doing something and it's like, this will never work, and then it's the only thing that works.
yeah, that's nice. Delete.
And the cool thing that you told me about this Onshape is that you can have two people doing it at the same time. With this setup live stream thing, I think it's best for me just watching you and you kind of explaining it. But I think that's pretty cool that you can go in and like dual create something.
Yeah, I want to do that so bad, you know. I haven't had a chance to yet, but I feel like doing these broadcasts and teaching more people, eventually it's going to happen, and we'll be able to do some really cool collab projects.
Yeah. Yep. I never knew something like that existed, so that's pretty cool. But yeah, we are trying to make a mini table to go in between my couch cushions, because I have a large sectional. You can probably see some of it behind me. That just has, it's just cushions and then sides. So there's nothing to put soda or bowls or anything. So I wanted something that could go underneath the cushion and kind of come up, and then have a platform up above to hold the sodas and a bowl or something. So we're just trying to work that out.
Well stated, my friend. Thank you for keeping
you.
the audience apprised. Oh yeah, nice. We got comments. Matt J, something. He said something in the comments. Awesome. I got in late. What are you trying to make? Or are you watching? You can't be watching comments. You just preempted his question.
I do see your comments there.
Oh, sweet. Nice.
Yeah.
Awesome. Yeah, so I can't wait until like I've got some more people up to date on this program that we could do like a dual design. Like I'm gonna work on this over here, you work over there, and just like watch something just grow. Different process. What are we gonna do here? Because we got an hour and a half left, and I'm fudging with the pretty stuff. What do I do? The normal two should work. Good. The bowl looks very good, yeah? You think it looks close to...
Yeah. It looks kind of like a pottery artisan bowl there.
Nice. You, and I want a chain selection of all of you guys, and I just want it to be normal to you for a while, but then you don't like that at all. Is it -1? No, it's not. See, this is why when I do my other broadcasts, like my YouTube videos, I put music in the background, but they kept on getting like taken down and demonetized.
Oh.
But like all the good music, you gotta pay for, right?
Yeah, of course. How they make the money?
Yeah. All right. This is pretty good. It's not flattening out too much. We'll call that good. Let's move on. If we come back later to it, we come back later to it. And here we will mirror entities and Onshape. Can I add planet? Can I add surfaces together yet? No? They really got to get on that.
adding surfaces together, so basically you just mesh it into one.
Yeah, because you can add objects to each other. Merge scope. What if I say merge with all? That can be tricky. Is it one? Oh, it is one surface. Nice. Thanks, Onshape. Way to go. Let me get that and that. Sort of sunk into that surface. That's cool. And then we'll just thicken that surface. You and you. And it will be by, we'll say 4 millimeters. I want to avoid making solid objects if at all possible, like big, thick, solid objects, because they take forever to print, and they warp on their edges. And
you have to worry about the infill. And
yeah, it's just not something. And the less you print, the faster it goes.
exactly.
And the idea about 3D printing is that complexity is cheap, if that makes sense.
Yeah, that does make sense.
If you look at like traditional machining practices where it's like, I want to make this product with a CNC mill, well, it's like, okay, that hole's going to cost you this much, this hole's going to cost you that much, I'm going to have to rejig it here to do that piece. 3D printing is just like all at once. If you design within the rules, it'll get made.
Yeah.
So there's that. I can hide this surface now. And then. Sorry, I'm just thinking.
No problem.
I actually want to change something.
Yeah.
So now we're going to look at the powerful power of Onshape with all of its power. This sketch first actually wants to be on a plane below. So I want to roll back to here. And actually before that sketch, I'm going to create a plane which is, say, 5 millimeters below. And then for this sketch, I actually want to change the plane that it was drawn on to this lower plane. And then this sketch, oh nice, because I drew this sketch parametrically to this one, when I moved it, because you see how I just moved that sketch down, this one still joins up, so I didn't even have to do anything there. Sometimes if you don't define things properly, you'll get, it'll turn red, it might be an error. There's some kind of missing reference that it doesn't have anymore that it thinks it should, and you might have to like reset something.
That makes sense.
This one actually, did it break the loft? Nope, sweet. And then we just roll to the end. Now we got a little bit more breathing room under here. Perfect. The result of that thicken is, if you can imagine, do you know what the word normal means in modeling?
No.
A normal, with any object, a surface will have a normal. Why am I using something transparent? Okay, so this surface, this flat surface, is a normal that is exactly coming like straight out of it at 90 degrees, right?
Okay, yep.
But when you have a curve, you've got to look at those normals as like you start at a point and then try to get tangent to every curve that it's touching, and it'll come straight out of the curve. So by thickening the surface that we created, we don't get a flat bottom anymore, right? Because this curve, like this point on this curve, points actually down, and over here it actually points down. And so you get these little sort of extra stuff. I want a flat surface because I want to be able to print that surface on the bed. So I'm going to split this. Split this with top plane, or not the top plane actually, that's too high. See it split? But I actually want to split with that new face. Let me plane. This plane 1. And that should split that. And then I'll click on this extra piece. And it's gone. And this one as well. Cool.
There we go.
So that will print on the surface. Actually, what am I thinking? I hope this is 246. What have we done? What have we done? I forgot. That's too big. Damn. Okay.
Well, it's 250 millimeters. Which way?
Anyway, your printer's a 200 by 200 bed, right?
Yeah. Well, it says on the official page it's 250 by 210, but I printed stuff bigger. I think it depends on. Or I mean, I've seen people print stuff bigger. I think it depends on exactly how you put it into the program.
Okay. What can we do? We want this thing to be. We want other people to be able to use it too.
That's true. Yep.
Most people are on a 200 by 200. We're gonna split it. We're gonna split. You got glue, right? You got super glue?
Super glue, yeah, I do.
Nice. Okay. All right. So we'll split it. And
no, you're right. It is 210. I was going crazy.
Okay. That's what we'll do. Let's do some thickening. This wall by 3. And this wall. This, that, this, that. New. Yes. Oops, that thicken didn't work on that one. Booleans. Booleans are the best. Onshape makes them very accessible. Fusion, not so much. And they do a lot of things. What I just did there was I took this one disk piece on the bottom and I added it to the cylinder piece on the side. It's a Boolean operation. You can do a union, like I just did. You can do subtractions, which can do a lot of cool things. You take one thing away from another thing. You can offset a surface on one thing to cut something else. And then there's intersects that are weird, and I barely ever use them. When I do, I feel really smart, but it's like when you take the intersection of two objects, so like a ball, like a sphere, and a rectangle. If you like mash the corner of the rectangle into the sphere and say, give me the intersect, you'd get like rectangle with some curve on the side. Yeah, I don't know. It's weird. So that's that, and I need, if you're like good and you want to work like slowly and like methodically on a model that you want to like come back to a bunch, it can help to like name your parts. You can see here I've just got like part 1, part 2, part 3, and I like have to kind of scrub through them with my mouse to see which ones highlight, see which one it is. But yeah, if I was like really taking my time, I'd be like bowl, and then I could go back to it. And also like with all of the stuff in the timeline, you can name what the move did, and then you can scrub back and be like, oh, this is where I cut the thing with the other thing. So you know.
Okay. Yeah.
And then there's much more sort of advanced methods where you can create an object, bring it into another drawing, and then go back to that other object to edit it and have it update. But it's not exactly helpful when you're new. It can be kind of messy to have a big giant timeline of all the things you did for like a huge project, but at the same time it's nice to have it all in one place. I've only just now started after like 2.5 years of doing this, doing like external imports and references and stuff. So everything I've made. I don't know if you've seen any of my stuff, like the marble lock and the business card embosser. All that stuff was done in one single part studio.
Okay, yeah. Yep, I saw that card embossing.
Yeah, everyone got really excited about that thing, and I like started selling it on like what was it, Etsy, and
Yeah.
you know how many sales I got from like going viral?
From going viral? I don't know. A couple, zero.
Zero.
Zero?
Not a one, man. The only sales I made were ones before that the articles went up, because I got on like TechCrunch, 3dprint.com, front page of Reddit for like a day or whatever. One, like zero sales. It was terrible.
Oh man. I guess in the day and age of like 3D printing, people just kind of expect, and I mean, I do it too. I see 3D model and I'm like, okay, where do I get the Thingiverse file?
Yeah, it's got to be free. If it's
it was designed, you gotta pay the creator there.
Yeah, no, that's the problem. It's everyone. Well, it's not the problem. Like, I'm only able to do what I do because people before me decided something should be free, right?
Mm-hmm.
So I can't complain. Like, it's part of the whole RepRap community is like people that built their own machines and then passed along the knowledge. It's the only reason. So, but at the same time, it's like, come on, I worked really hard. I want to make some freaking money.
Yeah.
Sorry, I'm just spending way too much time with this one move. Thicken.
Oh, no,
Okay. Cool. So that just gives me the actually offset surfaces. That thicken should be just like 3 millimeters. How much offset do we want on a cup? No more than like, especially if we know it's a can, we shouldn't give it more than 2 millimeters on each side.
Yeah.
So that would be
like wiggle room you're talking about?
Yeah. So that would be good. So those surfaces. And then we're going to do it one more time. This is actually getting really hacky all of a sudden. But it's fast because we've only got an hour and 20 minutes left.
Oh no! I think we got this.
Yeah?
Yeah.
Okay, good.
And then I have a good, like, I'd have a good basis to look at, and then it'd be something really nice to work off of, too. So even if we don't complete it all perfectly, I can work on it and stuff. So
Totally. So
and then you were talking about putting this up on your Thingiverse as well?
Yeah, mine or yours, whatever.
It'll be the only, if it's on my Thingiverse, it'll be the only one up there for quite a while.
Yeah. Well, then you start getting those likes.
Yeah. So are you going to, like, are you just modeling that so you can see it, or are we actually going to have the whole thing come up like that? Like for the soda can?
You'll have to be a bit more descriptive.
Yes. So in the model, you have that cylinder, except it looks like it's hollowed out. Like, are we going to put the soda can in that cylinder, or are you just going to...
I was thinking just the bottom portion here, but we could have it extend upwards if you wanted.
Okay.
But
I see. So those are just the shapes to look at it. I was thinking they were part of the model there.
They will be in a way. You'll see in a second.
Okay, yeah.
Sorry, just doing some kind of boring housekeeping stuff for a second here.
Oh, no, that's fine.
Actually,
I was just thinking about your comment earlier. The awesome thing about 3D printing is you're sitting there designing it, and there's this major problem that comes up where it's like, oh, it's too big. And it's like, you have super glue? Yeah. Okay. It's just so like, okay, we'll just hack this or do that, and it works. That's what I love about 3D printing.
Yeah, it's so accessible, right?
Mm-hmm.
Yeah, and it's only getting easier. Which is why I gotta step up my game if I ever want to be a pro, because you kids are coming after me. You've all had computers since you were youngins.
Yeah, that's true.
Not that I
What are you
haven't.
calling a kid?
I don't
I
know.
look a lot younger than I actually am.
Yeah,
But
I
I
look a lot
understand.
older than I am. We're probably the same age, aren't we?
Maybe.
How old are you?
I'm 25.
25. I'm 27 now.
Ah,
Yeah.
a little question mark there.
Yeah, I
Like,
forgot. I forget all the
yeah.
time.
No, I had that happen for the first time when I was 24. I was like, am I 23 or 24?
Yeah, it
Huh.
all blends together eventually.
Yeah, I get
What?
all sorts of comments about it.
Ah, this is above that face now. That's fine. I guess, maybe. Sketch. Split. Okay, now some fun stuff's about to happen, I think.
Okay.
We're going to do a subtract and reset our tool. Our tool is going to be this. No, our tool is going to be these. And our target is going to be this. And we want to keep our tools though. And yes. And then this, and this can go. And then do... Okay, here's a weird thing I'm going to have to do, because I need to cut both objects with each other. So, in order to do that, I got to go back in time, just before this Boolean, I guess. And then I want to do, this is a sort of hacky way to copy something. I want to translate something by XYZ. And this one is going to be the translated object. And I'm going to copy it. And I'm actually going to translate it by no dimensions at all, just to make a second version of it. And then I go back to the present day. And I've got two of these. Perfect. Okay, so the one with the stuff that's been cut out of it by the other thing, and then I'm going to start naming these things actually. Rename. One with the stuff. And then this one. One for the cuts. Okay, so the one with the stuff is fine for now. And then I want to use the one for the cuts, another Boolean. And we're going to do a subtract, and it's going to be one for the cuts, cutting these three things. Blammo. And then we got to take that, and this, and that, and say, go away. Don't like you anymore. And... okay, I see there. Screen face! Okay. What's happened here, as you can see, the bottom of the cups got cut with the bottom face.
Oh, I see.
I actually want to split it using that top surface. So that was the second operation. So actually, we'll just go to here and see if we cannot split this, and this using... Come on, it's a surface. There's a surface there. Offset surface, this and this by 0. Bam. And then split, damn you, this, and this using that surface. Does not split selected parts. Well, it should. Does not split all selected parts, or what? Or what? Okay, let's just do this really silly. In a really silly way. Just take a thicken off this. No, not you. One with this stuff. No, you. And you. Yes. And then this Boolean is just going to be using this silly part instead. Haha! Stupid solutions for the win. Ja.
If it works, it works.
We will see. We will see. One for the cuts. Go away. Yeah! See that? Flush. Flush mofo. Bam. It needs more holding it over here, doesn't it?
Yeah, that's what I was thinking. Yeah.
Okay. So let's Boolean this first. Because we can still move forward, because we can always go back in time.
There we go. That is really cool. Because if something we do here is just like, nah, I don't like it, then we can just pop back to the past.
Yep.
Okay, cool.
So if I'd named stuff, it'd be a lot easier. But here's this control area thing. So if I just brief on that a little bit, and then hit, it's gonna give us a little thinking, and it does give us a little bit more already, but maybe even more. This one?
Ooh.
No, not that one. It actually kind of looks like one of those masks, like one of those theater masks.
Yeah. Yep.
It's like the third one, because you've got the crying man, the happy, and then this guy's just like scared shitless.
Yep.
So that almost gives it sort of three axes. What's this? Another thing I can do is this and that, and it's going to give you the minimum distance between the two. So that'll be where it gets closest, and it's 7.6, which is probably next to nothing. 7.6 would even cover the bottom part that goes like that.
Okay.
It's looking pretty interesting.
Looks a lot more sleek than I was thinking.
Oh yeah, you hire Beta Things, you get nothing but the best.
Oh yeah.
See, I'm taking the most time on this part because it'll be the only part showing ever, and then the rest is going to be sort of sunken below your couch cushions. So. Just trying to think of a good way to raise that up a bit. I guess we can always.
Still making it look pretty good.
Yeah. I still actually think we could probably do a little bit here. Just go way high. Is that going to break everything? Super high center. Well, we're going to split it. So, worst case scenario, you can just print this off and test it with a can. I think it'll hold because you got like sort of 3 quadrants sort of covered.
Yeah, and I think if I push it back against the back of the couch,
Oh yeah, yeah, you'd be up against
It
that
kind of
back.
holds it on the back too.
Yeah. Okay. So we'll try that for now. We'll move on. We got an hour left. We got to do all the rest of the mechanics and stuff. Things are going to slot together and whatnot. Um, let's figure out our split. Probably want to split here so that we don't mess around with either of the cups. I guess we could just split down the center.
So how long is the, like, from the back of it to the front of it?
This whole thing was like 150 something.
Okay.
But that's why I gotta split it. Yeah, I think there's a line that can be had here. Let's say sketch on the top surface. I guess it doesn't really matter what surface actually. And just draw a line. Yeah. Yeah, there's room there for a line. You can split it there, say. Cool thing about Onshape too, which I haven't really explored yet, is programming. You can program your own sort of command sets. Like stupid stuff that I do every day, like draw a line and then do a line, like do a plane on that line. It could be done in like a single command, but that's what I'll be working on eventually. Because you can do really cool programmatic stuff, like the thing that I'm working on right now. It's a little sneak peek when we put in a video out in a little bit once it's done, and then the files are going to go out too. But yeah, it's based on Anthony Howe's kinetic sculptures. He had the kinetic sculpture. He had the thing behind the Rio flame at the Rio Olympics. It was that thing that was spinning behind the flame, but he's been doing it for years. So I thought I should probably try to imitate his work because I've pretty much imitated all of my favorite kinetic artists now.
Nice.
Cool. So that's split there, and
this split is being created to be able to fit it on the printer, or is the split being got it?
Yeah. So now we can just print each of the parts, and what'll happen is it'll be on the bed like that.
Okay.
And this will not require supports.
Nice. Is that back part is just going to be all solid with some infill?
No. That's the beauty. There's going to be.
That's not going to need any supports?
No, it'll be all bridging and acceptable overhangs. And because it's going to be on the back side of the print, even if you get a little bit of slop here, it'll clean up by the time you get to the front face.
It doesn't matter, yeah. Nice. That's cool.
And this one too should be good. Actually, yeah, we'll be fine because I'm actually going to put a slot here that the upright piece is going to slot into. And that'll actually support the bottom of this bowl when it's printing in this position.
Oh, yeah. Nice.
Did not plan this. Don't be impressed. just figuring it out as I go. Okay. So let's draw that thing we were just talking about then. Why not? So we don't have to cover the entire length, really. And this is where I pull out my calipers.
Handy calipers.
Yeah, always when I'm trying to envision something, it's so hard to get scale right on a computer screen. Like, Yeah, 20 mil. That's fine. And whatever that happens to be, sure. And yeah, let's just do this the fast way. Slow way is like sitting back and thinking like, what's the fewest number of moves that I can get this done in? The fastest way is just like, go, 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 sketch, another one, sketch, keep going. You end up getting a really messy timeline, but whatever. By 15 maybe? Oops, not 10, 15. 15. And yes. And sketch, another sketch. That's how you stay motivated. Say another sketch, another sketch, another sketch. Here, like that, there.
Okay, cool. So you basically just made a big block that you can kind of cut into on the bottom?
Yup. You got it. And then I'll do a mirror. This same thing. Ooh, what's going on there? It seems to be off-centered. What line am I on-centered with? Oh, this other square wasn't... The rectangle that I just threw up there wasn't centered. I can fix that. Oops. I just drew this rectangle here, and I was like, dimension, dimension, but it's not specified where it is in space. So I take the point, and then I put it on this line, and I constrain that point against this line with a midpoint constraint, so that puts that point at the midpoint of the line there. And then I use this point and this front plane, which I have a hard time selecting, and then I say I want that point to be coincident on this plane using the coincident constraint. That just moved it like a quarter of a millimeter, but centered it there. And now when I go back to that sketch, hopefully,
in the future,
yes, it's back in the center, or it is in the center now for the first time. And that's fine there. And I'll just blow through that whole object. Remove. So yeah, that's the cool thing about, you saw me do like cuts with booleans, but you can also do cuts just as you extrude something. I'm going to say through all as a remove. There's that. And then, ooh, do I still have something that represents the inside surface of this? Is there any objects still in play that do that for me? No. No. That's fine. And we'll just do it quick and dirty again. You're just seeing all of my bad design habits all at once. That's what this program is about, I guess.
Well, you gotta show the true process of designing.
Yeah.
No design is gonna be like, oh, boom, 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 done.
Well, it can be like that when I really when I spend like weeks in it, you know? You like do it 4 or 5 times, but then the 6th time you do it, it's like done. No problem.
Oh, okay. Yeah.
But yeah, for this one, hack and slash, I want it to take that surface and extrude it up to a surface, because Onshape does this thing where you can extrude up to a curved surface. But instead, I just blew right through it, and we're going to use a Boolean.
Okay.
So
yeah, that makes sense.
you are the tools, you are the target. I want to keep my tool. Done. And then you are just waste material. Quick and easy. And then I can do one more Boolean. I'm going to have to resplit this piece actually, because what's going to happen now is when I join this on to here, they will lose their split. But that's fine. I'll just split it again. If I wanted to, I could go back, move the split, deal with errors and stuff, but we're just moving forward right now.
You can get the rough draft down.
Yeah, so that's good. This will support the bottom of that bowl, like I was saying, when it prints like that, up and down,
Mm-hmm.
and it'll give you more room to put the glue.
Yep, there we go.
Um, yeah, sweet. Okay, so let's do that leg, I guess. The way I have imagined this is that this bottom of this surface would be like right on top of the couch cushion.
Yeah.
Yeah?
Yep. Yeah, that's what I was thinking.
All right. Yeah, that'll be sweet. It'll kind of look like it's bubbling out of the couch.
Mm-hmm.
Sweet. Okay. How long is this? 201 millimeters. Let's just make that a bit.
Oh.
We'll just make it a little bit thing. We'll just make it a little bit shorter. Even 150 is fine. Oh, 15. 150. And we can move it so it's a bit more centered. And even that's good. Bam. Compile. Perfect. Another sketch. Another sketch. Yeah, Onshape makes it so easy to just jump into a new sketch and keep going. Whereas with like, I'm always like hurting on other programs, but like Fusion and SolidWorks. Like if I wanted to, or like even FreeCAD, terrible. Like if you want to like draw on something, you gotta like make a surface to reference it first. I just click on a surface and I'm like, I'm gonna draw here. I'm gonna draw here and make something that's related to this thing now.
Mm-hmm.
So like I did a sketch on this surface, and we're gonna grab. This is the use. This is use, project, intersect. Very useful, where I can just say, I want this line, and I also want this line. Or if it was like way down here, this line, we would project it up. There it is. And what do I want? I want this line, and this line, and I want. Oh, this is where I need. I'm gonna need some measurements from y'all.
Oh boy. Do that.
So like the thickness of the couch cushion.
Thickness of the couch cushion from the base to the top is about 170 millimeters. And I think it was like 165, but I added a little wiggle room because it's squishy.
Sure. Okay. So 160.
Yeah, 170.
170. Okay. Cool.
170.
Okay. So what we'll do is we will take a point that is that, and we will stick a point down here, or we'll just put a line down here. Uh-oh. Uh-oh, my computer's starting to get upset. I can hear the fans increasing their speed. Not good. I mean, like I was telling Jay earlier, to our other 2 viewers who stick around. That's awesome. I'm running 3 different programs right now. I'm running my 3D modeling software, Zoom for meetings between me and Jay, and then OBS for streaming to YouTube. And this computer is, I mean, she's a beast. She's an old gaming machine that I got for cheap way back when. And I'm sure she'll be fine. Lots of life left. Okay, we'll give it dimension between here and here. And that was 170?
Yep, 170.
170. Cool. And okay, the difference between a regular line and a construction line. The difference between a regular line and a construction line is much different in Onshape. Onshape's much more permitting about these things. If you were using SolidWorks, which is very dogmatic in their approach, you want it to create a cylinder with some other information, I guess. If you like drew like a rectangle and made it a construction rectangle just out of this dotted line, and then drew a circle that was inside of that square with a normal line, You could extrude it out to make a can, like I did, and then the rectangle part wouldn't show because it's just a construction line. But if you made that rectangle out of solid lines, it would get very confused about what you wanted. Whereas with Onshape, when I create a sketch, I can extrude a portion of that sketch. This is probably not the place for this lesson. Here, let's just do a quick sketch and I'll show you.
Okay.
Just for random sake, because we got 50 minutes left and I'm feeling confident. So say I drew a circle and then a rectangle here, and I said just extrude that entire sketch. And it would actually do it for me. It would create a solid. SolidWorks or Fusion would get like so pissy. They'd be like, "What the hell do you mean? There's intersecting lines. It's not a closed geometry." Onshape don't care. Onshape's like Honey Badger. And then what you can also do, is instead of extruding the entire sketch, I can click a portion of the sketch that's defined by both shapes or the whole thing here.
Okay.
It's just so nice. Whereas, so if I was in SolidWorks and I just wanted this rectangle, I'd have to turn this circle into a construction thing. I would have to give it a dotted line so that it wouldn't get used. And yeah, so that's my little rant there. Anyhoozle.
Yeah. Basically, it's a lot more fluid, from what I understand. Instead of having to, it's a sketch in a sense. Obviously, it's a sketch, but it's just in Onshape here. You can create an object and just extrude and do whatever you want from it. Whereas in something else, you would have to make it just like an outline to do that.
It's just you'd end up having to do a lot more planning ahead of time. Yeah. This is where I earn my design points. What's that?
I like less planning.
Less planning, for sure. For sure. Because it allows you to be more creative. You realize something midpoint, you're working on it, and it's like, okay, let's just change it.
Mm-hmm.
And I with my process, I like to say print as often as you can afford to. Like it's crazy how much you learn about what you're making while you're printing little parts of it. Like if you can split off a part of it and print it and test it first, you'll learn so much. It'll change everything.
Mm-hmm.
Like this thing, I printed, the first thing I did was the little arms here. And I had to change the gears on the teeth and the arm's length and how I assembled it 4 times before I printed all 24 of them and then moved on to the drivetrain system. It's like you can perfect the first part first and then keep moving.
Yep. Instead of printing the whole thing and then realizing it doesn't work.
Yeah, and then getting super discouraged.
Yeah.
Okay, so this is that profile, and we'll extrude it in the other way, and then it's going to be up to the different ways that you can extrude something. Blind, which is just saying, I'm going to give you a measurement, I want you to extrude that length, don't care how, don't care what. Symmetric would be, here's your sketch, I want to extrude the same amount on each side of this sketch by whatever your final total is.
Okay.
Up to next is kind of a tricky proposition because next what Onshape defines next object, next vertice, whatever. Up to face, which is what I'm going to use. So I click on this face, and there it is. What else do we have? Up to vertex, which is up to a point. Up to part, through all. You can mess around with those if you want. There's a lot of different options there. And then you can say new, which is what I want to do, or I could say add, because it is like tight fit against that. I could say add, and it would just add to these things that it's touching. Remove, you already saw, is a cut, intersect, whatever. But we're going to do a new. And then we're going to apply a fit tolerance so that this can slide in, right?
Yep.
And that's really simple. It's, for our purposes, we'll probably use 0.25, and you should be able to just slide that right in the whole little dovetail there. And for that, we're going to do a Boolean with an offset. So our tool is this piece. Our target is going to be both this and that. Set U. Sometimes you can get blocked from selecting something by a plane. Oh yeah, I got both of them. Great. And then I want to do an offset, and I want to select the surfaces that I'm going to offset, which means I have to hide this and this, because I want to offset this surface, this surface, this surface, this surface, and that surface. I want to keep my tool. I'm going to set that offset to 0.25. And yes. And then you can see, got that little offset. It looks like a lot in here, but when it comes to 3D printing, that's like a tight fit.
Yeah.
I mean, unless you're moving on to like
5 millimeters is absolutely tiny.
Yeah. So this is where I'm going to start thinking about grain. So when you print something, you obviously know that there you get the grain of the material that you printed, right, by the layers.
Yep.
And you've probably seen how if you print a really thin like shaft up on the printer, it'll split. It'll break really easily, right?
Yeah, because
Because of the grain. So it'll be the same thing for this piece. If we printed it with this up orientation, there'd be a major chance that this center part would just crack, right?
that makes sense. Yep.
So we want to print it like this, so that the grain works with us, for us. And so that'll be the plan. I'm going to take a bunch of material out of here, actually, also, because I don't think this much is actually even going to be necessary. At our thinnest point, we're 5 millimeters there. So yeah, there's lots of meat that we can take out. So I will draw another sketch. And we'll use this as that. Hey. Should I do an intersect? I guess I should do an intersect. So the use was like a project. It's like from the normal of my plane, give me a projection of the line that I've selected in my sketch.
And it just throws it off into wherever.
Yeah, onto your sketch. What we're going to use is intersect, because the plane that I'm drawing on is this plane, right plane, the right plane here. Actually, let's hide some planes. Let's just hide some planes because they're all except for the right. Bam. Okay. And actually, I can resize this. Not that it matters. Planes are infinite in nature, but you can resize them just to see. So what was I talking about?
You were talking about putting, like, having the sketch throw it onto the plane.
Oh yes, right, intersects. Okay, cool. Yeah, so in the sketch, I want so this plane actually intersects the plane that I'm drawing on. So I use the intersection command, and I select that surface, and I get the line where it intersects my plane.
Okay.
And there. And then I'll actually use a use or a project on that line to get that. And then I'm actually going to hide that part for now. I've got this. And actually, I think I need to trim off some excess. Yeah. Trim this and this. And give it a little fillet. This will all make sense in a quick second, I'm sure of it.
Oh, yeah.
No, probably not.
Well, everything, it's on a slight delay, so there's lots of times where I'm like, yep, got it. But I know in a couple seconds here, I'll see exactly what you're doing, so.
Oh, there's no point radiusing those corners, whatever. 10's good for that. Oops. Trim and extend, these are sketch tools. I want to take this one and I want to extend it to that. That's the extend. Or if I want to trim, I actually just want to take that off. It'll trim it to the next line. Trim this, this. I'm just kind of free-forming this. Trying to provide enough structure, but not making it like just a behemoth to print. Cool. Let's do some extending. Some trimming. I started out designing years and years ago using AutoCAD. And I worked in a CNC mill workshop. So we had this big CNC router, and we did all these cool projects with it. But the comparison of sketching in AutoCAD, because basically AutoCAD is just the sketching part of Onshape here. The comparison is like night and day. It's so much faster with Onshape. I used to do all these crazy, silly things to make solid AutoCAD work. Okay, so that's should be interesting at least. Should be strong enough too, I think. Yeah. So what we'll do is we'll do a Boolean, we'll do an extrude to remove. So we're going to be extruding to remove from this thing. So we'll say extrude because I used construction lines and normal lines the way I was intending. You can see these solid lines are all things that I want to extrude to take out. So I can just select the whole sketch, and we're going to do it
And you're just gonna
symmetrically as a remove. And already selected the merge scope, so there's that. And finish it off with like a fillet or something.
nice. That's pretty cool.
Sometimes you fight with fillets because it's like, if they intersect each other, it's going to be like, no, I don't want to do it. And you have to like change your numbers and stuff.
Mm.
So yeah. Cool. And then just the base plate.
Which should be super duper easy. It's just another dovetail with a flat piece
Yeah.
of something.
Yeah, exactly. What we got? We got 47 minutes left, I think. But actually, I've got to remove some fillets here. And I'm wondering if I can use, I've never used the modify fillet command. Change radius to 0 for this one. No? Fine. Okay, so that sort of hero move where I was like, select this whole face and fillet it, is not going to work.
Yeah.
So I'll just have to select a bunch of lines here. Oh, it's getting upset at me.
Your computer or the program?
Oh, all of it, I'm sure. Okay, so let's just make it. This is going to be really weird, but instead of selecting all the faces on the other one to fill it, I'm going to split this thing. I'm going to split it. I'm going to delete half of it. And then I'm going to mirror. I'm going to mirror this piece and add it back onto itself.
So you don't have so many planes?
I just did this literally because I didn't want to select all those edges and recreate all the fillets on that side. But there you go. Yeah, because we needed this sort of corners here and there, especially on this side for print surface, right? You don't want to be coming off the bed doing much of a overhang because you'll lose it and it'll look ugly. So, and we can even go so far as to steal this geometry. I love stealing from myself. It's my favorite. New planes. With the top plane. This one. You can see how it's getting a bit busy in here. I'm gonna hide all sketches because I don't need those. I want plane 1. Where do I select plane 1? Where are you? Plane 2. It would carry then the plane 1 happens before that. There you are. Shloop. There, I got one too many things showing here. There. I'll say one thing for our viewers. They're like committed.
Yeah, they are.
I hope I'm teaching something. I hope that this is like actually helping.
Well, I'm learning some stuff. It's
Sweet.
not. I didn't expect to come in and be able to like do this and do that after I watched it, but I've learned kind of how it forms in the program.
Yeah.
I've learned some basic ideas to think about while I'm designing. Like I've never thought about the way that it prints could hurt its structural integrity.
Oh yeah.
So yeah, that's all stuff you have to consider.
Yeah. Okay. So here's a risky little move. I'm going to assume that the center, I get a center point on these arcs. I'm going to assume that's the center of the whole up and down bit of it. So I'll draw a line, and we'll create a plane on that line. This, I'm going to select line angle at 90. Little tiny cute little plane there, but it's infinite. It's bigger than it looks. And then what can we do is one more plane, which is an offset of that plane, which goes to like there, maybe there, and split this using this little guy. Bam, that. And this is all in the interest of avoiding doing the same work twice. That is all. So I'm going to take that, and we're going to mirror it on this plane, and it's going to add on to that part. Yes, go, done. Bam. And then kind of actually want this whole slot bit too. Ah, screw it. I'll just draw it. Because it was like 20. It's like 20 by 15. Yeah. And this is going to be an interesting one because this, if you remember, we took. Did we use this as the tool or did we use the slot? No, because we drew the slot first and we used the slot to cut the offset out. So this yellow piece has already been sort of downsized. Now it doesn't matter because we could just make sure that it always goes in this way. But if we want it to be sort of reversible, sort of better user experience, we actually want to make sure that this block is offset off of this yellow thing rather than cutting the same way. And so that should be fine actually if we just extrude this out and then cut with the yellow thing with an offset. Yes, sometimes it just helps to talk out loud. So this, and we're going to extrude it back. And we'll say, instead of blind, I want to go up to vertex, just that little point there, as a new thing, yes. And then we'll do our Boolean with offset, which is subtract, using this as a tool, having this as a target. Offset faces of you, 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 and you. Offset of 0.25, keeping the tool. Sweet. Okay, and now it's just sort of a little plate for underneath of the couch cushion. So what kind of special considerations should we think about here?
So if I think about the grain,
Oh yeah. So the think about the forces that it's going to be under for this case. It's going to be pushed. This whole top part's going to push side to side. So you'd want the grain to work across this way, right?
Perpendicular. Yep.
Yeah. So we want it to print in more or less this orientation, up and down, like the same way this upright piece is going to go. But how wide do you think it needs to be to kind of like comfortably grip a couch cushion? Is it are your cushions like really square, or are they kind of like squishy?
They're a little squishy.
Do you have one? Is like right behind you?
Kind of. It's a big one. Well, sorry, I just threw a couch cushion on my. There we go.
Oh yeah, yeah, typical couch cushion. Okay. Um. So I mean, okay, so like grab the pillow from like the top and the bottom, and like tell me how far you think it should stick under each side. You know?
Yeah.
I'd just like grab the pillow and I'd like, I don't know, move my hands around and just divine a measurement.
So we're looking at how far the base plate should be under the cushion here.
Yeah, what
Right.
should the anchor sort of thickness be?
Because I'm thinking if it's too wide, that'll add maybe too much force. Because that's more area for it to be pushing on. So I think I don't think it has to be too big. We did 100 millimeters on each side. That's kind of big. Maybe able to do less. Well, 100 millimeters on each side would make it 200 all the way across.
Yeah.
I think that's enough to hold it down on each side. So it'll be about 95 millimeters on each side, because there's a little gap between.
Mm-hmm. Yeah, because we got to work with that bed size. Okay. And because we're gonna be.
That's something that I haven't quite figured out how it's gonna work on my couch cushion, because sitting on it might change the dimensions a little bit, and I don't know.
Yeah.
That's something that I expected. I'm gonna have to go in and tweak a little.
Right on. Well, good thing it's at the end of our timeline, so it'll be really accessible. Okay, so let's just do a sketch then. Another sketch, and should it like kind of grip the cushion a bit? Should it be kind of like a?
Oh, kind of like some texture on it.
Well, I'm thinking just about like doing like an ampersand type looking, or what's that? The brackets that sort of like grabs the cushion.
Oh, I see what you're saying.
Let's make that like 90, because this is 20 already, so it's 20. We gotta go 90. That'll give us 20. That'll give us 200. Let's go 85 then. This is, yeah, we're gonna have to, might even have to do this in 2 parts or something, but we'll see for now. That will intersect fine. So let's just extrude it as a plane. Surface, yes.
You get your attention. Do you think the pressure of the couch will break the curve there, or are we gonna shoot it down so it's solid?
Well, I'm thinking that because like it's almost blocked, like it's almost like an umbrella, you know, like the top part, you're not going to sit above it anywhere,
Oh, that's true. You're right.
right?
Yep,
So
yep.
at best, you'd be over here somewhere.
Yeah, the
Um,
closest you can get is right to the edge. So
mhm.
yeah, that's true.
And actually, I should turn that off. Turn the surface off. So you got your printer all ready to start on this thing like tonight?
I do. Yep.
Oh, sick. You're
Yeah.
gonna send me all the pictures, right?
Oh
Nice.
yeah, I will.
Sweet.
I have to figure out how to like convert it to STL and all that stuff and put
Um,
it into Cura. That shouldn't be too hard.
yeah, I can definitely help you with that too. And I'll do an export as an STL here, no
Okay.
problem. Yeah. So yeah.
Nice. Pretty much done. It's awesome.
Yeah, you like it? Good.
Did you what?
I said, do you like it?
I do. It looks so much more. It looks nicer than I thought because the sketch that I had was literally what I thought it was gonna look like.
Right.
Just a block with like 2 circles in the middle. So that looks a lot nicer. I don't have to worry about infill or supports or anything like that.
Yeah. Yeah. Because yeah, even the centerpiece printing in that orientation, those overhangs are fine and they join up, which makes them strong. Should have no problem printing any of this.
Yeah.
And you know what? I might even take a little bit of material out of these,
Okay.
just because of printing time. Because we've got 20 minutes, 20 minutes to spare.
Yeah.
That's pretty good.
Yeah. From just measurements to having the product pretty much done. Well, of course, there's going to be a little adjusting, but
Yeah, there'll definitely be a little bit of trial and error, I'm sure, at some point.
my cat even made an appearance on the stream.
Oh yeah.
That was cool.
What's your cat's name?
That was Cass.
Cast?
Cass. Cass.
Cast the cat.
Yep. Cass cat. I moved the couch cushion just enough so he was trying to crawl in under it. Yeah. Cats do what cats do. Oh, are you going to take out some of the stuff in the base? So it's just bigger? Cut out that circle there?
Yeah, and I'm using the shapes that I use here are very important as to what they are. These ovals they're not going to create like terrible overhang situations. Like they only start to be a bad overhang here, and that's right before it gets into doing a bridge.
Okay.
For printing, you know.
Mm-hmm.
For our two viewers, overhangs are an outcropping basically of material that you're printing on top of each other over and over and over again. You can usually achieve an overhang of about 45, 50 degrees before you start getting a layer kind of flopping down because there's nothing underneath of it. But if you have two walls with a straight line between them, that's called bridging. And you can achieve bridging distances of like 100 millimeters and not have too much sag even really if you got your printer calibrated properly. Unfortunately, because this is a curved surface, the bridging wouldn't work because it just tries to pull a filament, an extrusion from one wall to another. So if I were to do like straight lines here and just do straight slots, which I kind of originally wanted to do just now, the bridging wouldn't work. So we'll just do it like this.
Mhm.
There. It looks very McDonald's right now with the colors that got automatically placed. You should sell that to McDonald's.
There we go.
Yeah. Okay, cool.
Nice.
Let's I'll just export this stuff and we can close up shop for the day, I think.
Cool. Yeah. Yeah.
This piece, this piece, this piece, and that
Oh,
piece.
we need a name.
And then I'm gonna say export. And we'll call it did we come up with a better name?
I was just thinking about that. I haven't yet.
Okay, soda platform. We'll say code name soda.
Code name soda. I like it.
And it's I can export as STL, Parasolid, SolidWorks, whatever. But yeah, I'll do it as an STL for you, and do it as it'll export as a zip file containing all of these parts individually, so you can import them individually.
Awesome. Yep, that helps a lot.
And that's downloading. Cool. Well,
Nice.
thank you to our 2 viewers for tuning in to the first ever live 2-hour prototype session with me, Paul, and Jay Allen. I have a last name too, but
Yeah.
anyways. I am now, well, coming up in a couple days, like I said, it's going to be a video once this is complete. I'm not going to release it into the public like I normally have right away. I'm going to be taking on, well, like I say, I'm taking on students right now, but I'm also going to be taking on what I'm going to call apprentices. So they'll work with me on these projects and help refine them in order to be released for everyone else to print. I've got a backlog of old projects that I've already released on Thingiverse, but they're not sort of friendly enough for the everyday printer. So that'll be sort of the first project I'd try to get the apprentices to work on, and they'd work with me and learn while they're doing it. So yeah, if you're interested in lessons, let me know. Those cost money. If you are interested in being an apprentice, you can also apply. Just send me a personal message on YouTube. See you in like a week with... I can't stop holding this thing. I'm so excited.
It's pretty cool.
All right, I'll shut down the broadcast now. Thanks for watching.
Thank you. That's pretty cool.
Well, you can stay for a second. I'm just gonna stop the. Okay, stop.